Hello everyone, welcome back to our channel ML for Analytics. Today we will be covering model relationships in Power BI, a very important topic of Power BI. So let's get started. So first of all, let us understand what is the purpose of relationship, as in why we are using this relationship in case of data modeling, in case of Power BI. So what is the idea behind using relationships? So first of all, it enables the filters that are applied on one table to propagate to other tables that are related to it. So suppose there are two tables. One is the product table, the other is the sales table. Both the tables are having many one to many relationships between them, as in the product table is on the one side of the relationship and sales table is on the sales side, many side of the relationship. So in that case, what like by means of any column that is residing in product table, I will be able to filter the columns that are residing in sales table, and they may be having connection, they may be having relationship between them by means of any key, by means of product key. So that is the idea behind using relationship. This relationship, it actually creates a path of propagation of filters. So filters will be using this path in order to propagate. So if path to keep the tables related is there, the filters will propagate along the same path. I have created an example over here. As you can see, I am having a table, domain key, uh, domain table. It is having one column which is domain key, having another column which is the domain. uh, domain table is related to employee table. Employee table again is having four columns and three rows, and each of them are having domain keys over here. So again, this is there lies a one to many relationship between both of these two tables, as in domain key will be unique in case of domain table, but it will be repeated in case of employee table. So by means of domain key, I will be able to filter the the rows which are there in employee table. If I talk about this table over here, it is actually telling me the CTC of these employees. Again, this particular table, the CTC table, is related to the employee table by means of employee key. Again, as you can see in this table, 1 comes twice, 2 comes twice, 3 comes twice. So again, this is actually the many side of the relationship, and the employee table, since it's having employee key uh, just once, this is unique. So this is on the one side of the relationship. So in our case, star denotes the many side of the relationship and one denotes the one side of the relationship. If I talk about these two tables, I can see that this is again a CTC table, this is again year table, and I can see that in year table, each of the years they come once, but in CTC table, the years are on the many side. So again, this is actually a one to many relationship with year table on one side and CTC table on the many side. Now suppose I want to see that in finance domain and in the year 2019 what was the total package. So or you can say the total CTC. So what I'll do is, corresponding to finance, I can see that the domain key is DOM2. By means of DOM2, I will be able to filter the employee table. So I can see that DOM2 is on the second row and it corresponds to Arun, the employee key of whom is 2. So I will be able to filter this table, CTC table over here, and I can see that corresponding to employee 2 I have 2 rows available over here, but I actually wanted to check the CTC for the year 2019. So this is the row which is satisfying all the criteria that I have mentioned just now. So the outcome that I am getting, it is 7.5. So by means of this, I was able to explain to you how the relationship propagates among different tables, and how we can utilize relationships uh, uh, propagating within models in order to fetch data of our choice. So this is A. Let's now move to second concept, which is the concept of disconnected tables. So guys, sometimes it happens that uh, though we need a table, but uh, that table may not be, you can say, used in the model. So disconnected tables, they are tables that are not related to other tables of the model. So that is, in case of the model, I will not be needing this table. I will not be having this table related to any of the tables. These tables, they are not intended to be used to establish relationships and to use them as filters. So as you can see that I want these tables to be just used as filters. I don't want them to be used in order to establish relationships. They are not part of my model, but I will be using them as filters. I'll let you know how. They are intended to be used to take user inputs and act only as parameters. That is, I want them to just act as parameters. Those parameters I will be able to use in order to take user inputs. So I have actually created an example over here. So many of you might have heard of gradient descent algorithm of machine learning. It's a very famous algorithm, and it has got learning rate which is made to vary when we actually do iterations, and when we actually do simulations. We want to see at which learning rate we actually uh, satisfy some of the constraints that are mentioned in this algorithm. So I have created a dashboard which is actually on this algorithm, and I want learning rate to vary. So what I want is, a user may actually select whatever learning rate he or she wants, and he wants to see the simulation. So in that case, what I'll be using is, I'll be using generate series function of DAX in order to generate a series from 0 to 1, and simultaneously I would have also be creating a parameter. That will be the parameter which will be available as a slicer in front of the user, and when the user changes any value in the slicer, that value will be reflected in my measure, and that measure will be used in place of learning rate in my gradient descent formula, and using that formula I will be obtaining gradient descent curve. So this will be the whole flow, and you can also use but if parameter of Power BI. This is another feature. We will talk about it very shortly in the next video. So this is how we use disconnected table. This is the usage of disconnected tables. Then we have relationship properties. So in this video we will talk about 4 relationship properties. The first property is cardinality. The first cardinality is the 1-to-1, which is very infrequent. It is not used that often. So in this case, both the tables that we are having, they are both of them are having unique key values, and they are related by means of those key columns. uh, but why is it used infrequently? It is actually that uh, there is no reason to create two separate tables. In this case, we can merge both these tables into one, and then actually can use it directly then to create a flow, a relationship flow. So this in case of this cardinality, I'll recommend you to actually merge these two tables together and then use the columns and the table as just one, rather than creating two tables, establishing a relationship, making the relationship propagate. Then comes many to one or one to many. Again, both of these are one and the same thing. As in case of many to one, the first table, the left side of the table will be having duplicate rows, or you can say duplicate keys. But in case of the right table, that table will be having unique keys. So that left side table will be on the many side, right side table will be on the one side. In case of one to many, it will be just reverse. So this is actually frequently used. uh, if I talk about star schema, the fact side of star schema, it will be on the many side, and the dimension table will be on the one side. So generally what happens is that one side filters many side. Then comes many to many, very infrequently used, but in this case, both the key columns, they are containing duplicate values. Then comes cross filter direction. This is another relationship property. It is used to define the direction of filter propagation. So uh, this actually lets me know towards which direction I want relationship to flow, towards which direction I want to filter to propagate, as in which will filter what. So in this case, in case of one to many or many to one cardinality, I have two options available. In case of cross filter direction, one is single, the other one is both. In case of single, one side filters the many side. In case of both, even many side will be able to filter the one side. In case of one to one, I have both cross filter direction available with me. So any of the table can filter any other. So it's like table 1 can filter table 2, or table 2 can filter table 1. In case of many to many, it's single. The left table can filter right table. It's again single. The right table can filter the left table, or both. As in any table can filter any table. So it's in that way, which should be discouraged. Many to many and then both also, not a very good combination. It gives rise to many problems in your data model. It should be discouraged. So then comes make this relationship active property. So actually guys, when we create any relationship, the relationship between two tables which we created at first, it will be an active relationship. As in, uh, the filters will always be moving in that particular path which will be specified by the relationship which we created at the very first time. After that, whatever amount of relationship we create between two tables, they will remain inactive unless and until we deliberately make them active. And at any point of time between two tables, only one relationship can remain active. So it's like active relationship, they are the filter propagation path, default filter propagation path, which are used by the model. If by any chance you want any inactive relationship to be used for one particular scenario, as in you have in your model you want one relationship one to be active all the time, but in just one case, one use case, you want an inactive relationship to uh, stay active, as in you want the that path that filter propagation path to be available for some calculation. Then you will have to use relationship function of DAX in that case. In Power BI, an active relationship is represented by a solid line and inactive relationship is represented by a dashed line. Then comes assumed referential integrity. This is another relationship property. Uh, so this actually is available on in case of three conditions, as in these three conditions they need to be satisfied if you want to use assumed relation referential integrity. The first condition is that one to one or one to many relationships should exist between the two tables. The second condition is both tables should be using direct query method in Power BI. The third condition is actually that both tables should come from the same source. So I'll show you where this is available. If you go over here and if you go to model view, and like if you double click on this over here, as you can see, this is actually the make this relationship active property. You have this assumed referential integrity over here, which is actually blurred out because currently I'm working in import mode. So if this was I was using direct query method, and in that case I was creating a relationship between these two tables, then this option would be available to me. It would not be blurred out. So what does this do? This actually is a feature given in managed relationships window, as I showed it to you, and if enabled, the native queries that are fetching the data from data source will be doing an inner join of these two tables and not the outer join. So in case of inner join, only those rows will be returned which are actually having reference in both the tables, as in there is no mismatching of the keys on only the rows which are matching, they will be returned, and any rows which are not matching, which are blank, they will be excluded. So this actually improves query performance. So that's why we use assumed referential integrity. So this there's a case study that suppose two tables that are product and sales, they are having one to many relationships. Sales has got one product, the ID, for which some of the products they don't exist in products table. In this case, enabling this feature will result in the exclusion of the unknown product, as the two tables will be inner joined. So this is what assumed referential integrity is. So guys, here I conclude this video. Click on like button, comment, share and subscribe to our channel. Stay tuned. Thank you.